Hi everyone, my name is Vinayak Hegde and I'm a principal AI advocate at Microsoft. Welcome to the AI Genius series. This is the first part of six-part series. So I am one of the series editor along with Priyanka Vargadia, who is a senior developer engagement strategy manager. And these are the different sessions that we'll have. Today's session is on explore cutting edge models. I will leave this on the screen a little bit so that you can actually scan and register. If you are not registered for the other sessions, it takes you to the registration links. So we have a big lineup of events available to you, which will cover various aspects of building AI applications and productions in production. So without further ado, let me move on to today's session, cutting edge models, LLMs, SLMs, and more. So we'll try out different kinds of models that are available there, and I will give you a brief overview of how each of these work, what are the different patterns in making this work, and what are the challenges in maybe selecting some of the models, right? So all of this content, including most of the slides as well, except a few customizations, are available in the repos, and I will give you a link to all of the code, all of the slides, so that you can try it out yourself. Cool. So let me talk a little bit about the agenda. So I'll do a quick intro of the different kinds of AI models that are there. Then we'll talk a little bit about model selection and the criteria to help guide towards the right model. We'll also then look at where the various tools that are available for model evaluation and comparison, and how we can actually figure out what is the best model for your app. We'll also look at some case studies of customers who have used um, some of these models, and um, so we'll look at the different aspects of model evaluation and comparison, and then eventually we'll conclude with some of the links that are there, and open the floor for some Q&A if we have some more time, right? With that, let me move on to the start off with the presentation. Yeah, so generative AI is revolutionizing industries as the greatest force multiplier. It has enabled unprecedented innovation and efficiency. Over 53,000 organizations are leveraging Azure AI services to scale and create transformative solutions. From automating complex processes to enhancing customer engagement, boosting productivity, developing new products and services, Azure AI empowers businesses to achieve more, and its robust tools and frameworks ensures seamless integration and scalability, um, helping you drive a significant value and competitive advantage. Right. So these are some of our customers, and some of the use cases that they have been able to build on. So let us quickly blow this up and make it more tangible. If you see on the screen, there are different kinds of categories: automation, personal productivity, customer engagement, products and services, that you have to use, and then you look at some of the capabilities that are there for each of these services. For example, if you look at personal productivity, all of us have been using maybe ChatGPT or some of the other tools, whether you're doing ideation, coding, learning, designing, writing, reporting. You are using these models yourself, and it helps you in various kinds of things. For example, translation, multimodality. Like for example, you have certain images or generating images or like consuming images, or you want to summarize a piece of text, or you want to chat to a chatbot. So all of these applications are available, and they kind of help you, either automate, make you more productive, engage your customers, or build completely new products and services, because the paradigm with how we interact with computers, especially with the human-like text, has changed quite a bit, right? Always we used to interact with computers using programming languages, and now we are kind of we can interact with them using natural language. So this is definitely a game changer. So a little bit look at the stack. So from the code to the cloud, this is like our entire tool chain that we have available at Microsoft. Today we will look at maybe the Azure AI Foundry, which was earlier called as AI Studio. We'll also take a look at GitHub Enterprise a little bit. We'll also look at the model selection on the Azure portal, and we also will look at the Visual Studio Code, that is available to. So these are kind of the suite of products that are available, whether you're building locally and you're building locally and uh, pushing it to the cloud as well. Cool. So with that, let's look at the services, some of the services that are available. So Azure AI offers best-in-class foundational models, empowering businesses to develop and deploy custom solutions. Um, AI services developers can quickly integrate advanced capabilities such as speech, vision, language into the application. The machine learning provides a robust platform for building and training and deploying machine learning models. So if you have own models, you can use Azure ML. It supports end-to-end workflows and helps foster collaboration between your data scientists and developers. Uh, to ensure ethical and responsible AI development, Azure includes responsible AI training, which helps you identify and mitigate bias, ensuring fairness and transparency. So all of these tools are seamlessly integrated in the Azure AI Foundry, which is our comprehensive platform that simplifies the development process from ideation to deployment. By combining these different tools, Azure AI enables organizations to create innovative, reliable, and ethical AI solutions that drive business growth and enhance customer experiences. Also, we'll see a demo of the AI toolkit for VS Code, which is a Microsoft extension. You can download and experiment with generative AI models. You can fine tune and optimize your model with Olive, and you can deploy your AI application and model to the cloud or on device. So we'll see an example of this further during the session. Um, so before we go on to the next part, I just want to quickly talk about how language models work, because a lot of you might not be very familiar with this part. So I just want to give a small primer on how language models work. So most language models, what they do is they predict the next likely token, especially text-to-text language models. And this is how the typical workflow works, right? So the language model receives raw text that it then tokenizes the text, as you see in the pre-processing stage. Then the tokens, which are basically chunks of text, and we'll look at it in a bit, which are depicted in the diagram with different colored boxes. And then these tokens are transformed into integers that are fed to the model. The model is a transformer architecture based neural network. We don't have time to cover all of these, but essentially the goal of this model is to predict the next word in the sequence, which leads to model sampling a probability distribution that results in the final text and token, right? So the general idea is you go from a text to token. Tokens are numbers. Numbers go into the model, and the model samples a probability distribution, then outputs a natural language uh, output, which is a single token. So this is how it works, right? You have n tokens in and one token out. So what are tokens, right? I've been talking about tokens. So token is not necessarily a letter or even a word. It could be part of words. As you can see, um, the sentence on my screen, and this is one of the tokenizers. You can try out your own tokenizer or the same one that I'm showing it to you on platform.openai.com/tokenizer. So a token is a short sequence of letter. A token can be a short part of a sentence or a word, or it could be just one letter, right? So this is what tokens is. So whenever I'm referencing tokens, this is what it is. And what you see in the screen is a tokenizer that we have used is the OpenAI tokenizer. So going back, right? You have n tokens in and one tokens out. So we have put in we need to stop anthropomorphizing, and then izing is like the token. Anthropomorphizing has been um, broken into three tokens, and this is how it is kind of building upon itself, right? We start with we need to, and then it says we need to stop, takes that token, puts it back into the model, then it says we need to stop anthrop, and then so on and so forth. It goes back to the model again and again, and whatever text is generated is fed back into the model, and that's how it does. And we'll see an example of this generation as we go along. So I talked about a probability distribution, right? So let's kind of delve into the selection process. The model chooses the output token based on its probability of occurring after the current sequence. This probability distribution is calculated using the model's training data. We are looking at the inference step, but before you can do the inferencing, the model training is the step that we need to take care. The model doesn't always just choose a token with the highest probability from the instrument. To simulate the process of creative thinking, a degree of randomness is introduced. And this is why most of the models are probabilistic, and this is what kind of makes AI applications different from our deterministic applications. That every time you generate um, using the same prompt, everything is the same, all the parameters are the same, you will typically get a different output, right? Even if you set the temperature or the top p value. So there are two kinds of fine tuning that are available, or parameters that are available when you send this data to the model. One is called temperature. You often see a scale from 0 to 1, which controls the creativity or randomness. So lowering the temperature will create more deterministic results, whereas increasing it will increase randomness. There's also another one called top p value. So you'll see that on a scale from 0 to 1, and essentially limits a distribution to whatever specified. For example, 0.1 will limit the sampling to the top 10 percentage of value, which will make it determined and focused, right? So we'll see an example of this as we go on. So Azure AI Foundry actually gives you access to a lot of models. So these are some of the models that are available. There's a Microsoft family of models, the five family of models. There is the Cohere, Mistral, the Meta, Llama series of models, the NVIDIA family, and obviously there is models from Azure OpenAI, and also Hugging Face. So there is also an opportunity to use the GitHub models, and we'll see a demo of this. So you can experiment with AI models in the playground, which is like a window which has which shows you the output. You can chat with the model, set the parameters. So you can unlock the full potential of AI with the model card, the playground inference, and SDK for models. And I want to set the stage, and we'll see examples of this as we go into the demos. So in the single UX, the businesses can experiment with any of the model families highlighted here. And even this doesn't capture everything because there's huge number of models out there. And we'll talk about, how is the model selection process as we go on. So let's look at the model card. So this is like the Azure model card. When we go to the Azure AI catalog, this is what we see, right? These are the different models that I showed you. These are the examples of model. For example, you can see the one preview from Azure OpenAI. You can see the Ministral 3 billion parameter model from Mistral. Then you can see the Llama model, 3.2 model, which is 3 billion parameter model. So you can see all of these different models that are there. And then each of these model has a model card that is associated with it, which gives information about the particular model. That tells you that what are the capabilities, limitations, and use cases of various models with the model card. You can experiment with these AI models in the playground, where you can test and fine tune them to suit your need, and then you can customize and fine tune this model with your own data, making them perfect for your specific needs. So the integration is seamless with managed instances, automatic scaling, using smooth deployment, plus the task-centric exploration feature lets you experiment with models in a user-friendly playground. Uh, GitHub similarly has a model card and a playground that you can use, and we'll see an example of this. So GitHub gives you an opportunity to test out these models for free. For the Azure AI playground, you need to have a subscription, and you need to deploy the models, to try them out. But actually, the GitHub model actually helps you play around with these models, especially if you're trying out something new or want to look at a new model. I think I would highly recommend this. You need a GitHub account for this, and you can actually use these AI models very easily in the playground, um, to try them out. Again, you can use the playground inference API and the SDK for models. Um, these are these make it easy to switch between models, compare different models, and we'll see examples of these. Cool. So I just want to talk a little bit about prompting and give an example of that. So what I'm going to do is I'm going to take two models. I'm going to use the model to generate prompts, and that prompt I'm going to feed to a Microsoft Design DALI to create an image. So just to kind of go into detail of what I'm doing, I'm taking a prompt and I'm using that to generate another prompt which can be fed into the model. So for example, I have given the GPT prompt here, generate a prompt for a hyper realistic portrait of a pirate. You can see that it has generated a a very detailed prompt, um, and it says hyper realistic portrait of a pirate, grizzled beard, weathered skin. It has told you the camera, the backdrop, the lighting, the contrast, vivid colors. Similarly, now if I use another model, GPT 3.5 prompt, and I have given pretty much the same prompt, and I will see that it has generated a fairly long conversation like model, and you can see that there are some key differences. For example, in GPT-4, it has provided more vivid and very precise descriptions. GPT-4 is more advanced, allowing for more richer prompts. GPT 3.5, on the other hand, is tuned for conversational tasks, making it a little more verbose. Um, but in conclusion, you can see that the kind of image that is generated, uh, the what GPT-4 prompt is like very hyper realistic. You can see the lighting is good, the depth of field is shallow, just as we said, the detailing is like really good, and this is just because the prompt was like very specific. So the key difference is, as I said, like detail and realism. GPT-4 image is more detailed and realistic. The visual impact is more striking, and the appearance and the color is more vivid. And this kind of tells you, the complexity and the nuance that is there between the different model. GPT-4 also is designed to be more safer and more aligned, reducing the likelihood of generating harmful or incorrect um, content. So with that, let's look at the different languages of models that that we have in the catalog, and that you can use in your app. There are, among many types of model, one of the ways of classifying the models is based on the they are uh, context, in the sense, uh, um, the number of parameters that they have, the kind of latency they bring to the table, and also the kind of output they can give. So we are comparing two different kinds of models. The large language models, or LLMs, I think all of you are familiar with. They have made a huge impact over the past year, becoming known even beyond tech circles, right? So these models enable impressive knowledge-rich interactions, but they also require significant computing resources. So not all organizations have this level of power or compute resources, and this is where the small language models come in, or SLMs as they are called. They offer domain-specific capability with greater compute efficiency. Microsoft introduced a 5.3 family of SLMs. Recently, the 5.4 family of models was also released, and they are available in three sizes: mini, small, and medium. These SLMs are accessible through the model catalog, and Microsoft continues to provide the best models across the quality spectrum, with the 5.3 release enhancing flexibility for customers. So you can choose the right model for your needs: efficient and domain-specific SLMs, or versatile or contextual LLMs. And we'll see an example of this as we go into the demo. So I want to kind of make this comparison a little more detailed, and in terms of technical capabilities, how does it look at? Language models are essential in natural language processing, helping machines understand and generate human code. There are large language models like GPT-4, which has 175 billion parameters. It requires significant computational resources, but excels in complex tasks, understanding context, handling diverse languages. However, they come with high costs and longer training times. Small language models, on the other hand, have fewer parameters, makes them less intensive and faster to train. The ideal for simpler tasks and edge device deployment, but may struggle with nuanced language and text. And we'll see an example of this when we do the demo. But largely, you can see uh, the differences: fewer parameters, more parameters, less computationally intensive, more significant resources. There are always also advantages and disadvantages, like faster training and inference time for SLMs, but superior performance in diverse NLP tasks. Right. So based on what is your requirement for your app, you can choose the right SLM, and then, or LLM, and then you can fine tune that SLM or LLM based on the kind of compute power you have, the inference time that you can live with, and also the kind of deployments that you want to do. Many of the SLMs can be downloaded locally, so you can also run them on edge devices. For example, you can also run many of the SLMs on your mobile phone. Again, but they do come with some disadvantages because you have limited performance on some complex tasks, and again, might struggle with diverse languages. They do not have the world knowledge which kind of LLMs have. But again, like, the best model for your particular use case is what you should choose. So I'm going to do a quick demo of Mini 5.3 Mini, and what we'll do is we'll take a image PNG and convert that into code using 5.3 ONNX model. This is a local hosted models, and we'll create a matplot Python version of the same. So let me just go on to my demo screen. Let me just go to the Explorer. Um, Okay, so this is, by the way, this all of these source code is available, and it's available for free to kind of maybe incorporate in apps or test it out. So here I have actually opened a code space from the module that I'm actually taking, and what I'm going to do is I have already like chosen a base a Python version, a kernel as they call um, in Python notebooks, Jupyter notebook, and I'm going to run everything, and it should generate an output. So let me run all, and you can see that it is now running uh, the entire thing. It is tokenizing. I've set certain options like max length, temperature. Then I'm selecting the SLM. I'm encoding the prompt as I said earlier, and then I'm going to loop over the output which we saw earlier, and you can see that it has generated the output saying "I'm an AI language model created by Microsoft, exists in purely in a digital realm and don't have a personal experience. But I'm here to help you answer and assist you with any information task that you need. How can I help you today? Right? Now we are going to look at a little bit of multimodality. So let me go to the next example. Here I'm taking the ONNX runtime. I'm using the 5.3 vision model, which is a multimodal model that can actually read and write images. And I'm going to run it. Again, I've chosen the base kernel as Python 3.12.8. So let me just quickly run, and then we'll look at the output. So I have given it a demo a PNG file, which should be here. This is the file that I've given it, and I'm asking it to interpret this file and generate code for it in matplotlib. So it is still running it. So it has read the PNG file. It has created a processor stream. I have given it a particular prompt, as we saw earlier. Please create the Python code for image and use PLT to save the new picture under IMGS and name it 53vision.jpg. Um, and I've given it a bunch of parameters. So here it's opening the image file, and it has run all of this. It's pretty fast. Um, and again, like, it is looping through and generating the stream, and you can see that it has generated the source code in Python. It is importing matplotlib. It's figuring out what is the data to plot. It has created a pie chart and set the title, and now it's going to save it in the jpg format. So now we are going to run the code and look at how it looks. So let me just go there. Yeah, so this is how it has plotted the image. Here you go. It has plotted the image, and this is actually built from like the PLT, and it has also saved it in the uh, lgpt 5 vision, which is kind of displayed here. And you can see that this is a pie chart, and has regenerated it using PLT. It has generated the code, and it has generated the image using uh, using the parameters that we have given it. Cool. So we have seen this. Let us now go to the presentation again. So next we are going to do demo of comparing the SLMs versus LLM, and we are going to do this using the GitHub Marketplace. So let's go to the GitHub Marketplace. So you can go to the GitHub Marketplace of models by going to this URL, that is github.com/marketplace/models. So yeah. So what I do here is, by the way, this marketplace of model is free for everybody to use. And you can see in the drop down, when I select the model, it's giving me access to a bunch of models. There are models by OpenAI, there are models by Phi, which is Microsoft. There's models by Mixtral, Cohere, 821 Jamba. There are Llama models as well, and all of these are running in a running remotely. So I can choose the model that I want and interact with it. For example, let me choose GPT-4o. So I've selected this model, and this is the playground that I was talking about. As you can see, there's an area where I can type the prompt. There is an area where I can see the uh, uh, output, and then I can control the different parameters, the max tokens, the temperature, top p that we talked about. And you can see some details about the model, like this multi-purpose, multilingual, multimodal chat completion model. So I can ask it what is a pulsar, and let's see what output it gives to us. So it's running pretty fast, and it has given a fairly detailed overview of pulsar. So pulsar is a highly magnetized rotating neutron star that emits beams of electromagnetic radiation out of its poles. And I can, at the best part is I can see the code that is it is using to generate it. I can also get an API key here, and I can choose the language that I want. At the same time, I can also use the Azure OpenAI SDK, AI Inference SDK, or the OpenAI SDK, and I can run it, create a personal access token. I can install the dependencies. I can run a basic code sample, and also I can explore different models. So all of it is kind of inbuilt. And if you want to go beyond rate limits, you can avail that facility as well. Um, the best part though is this small thing that we have called compare. So typically when you're doing model selection, you want to compare two models, right? So we talked about SLMs and LLMs. So now let us do a comparison. Let us choose Phi 3 Mini Instruct 128K. Let's choose this model. And now it has reset the prompts, and you can see the models side by side. So it has replicated the playground. Here I'm going to type the same query again, and let's see what is the difference. Because I've talked about the differences, but what better to see in the demo than what are the differences and how it responds to the same question. So I'm giving the same prompt. What is a pulsar? And both of them are generating, and you can see that in GPT-4 the output is very rich. It's also segmented, well thought out, well formatted, so it has a lot more information. If you look at Phi 3 Mini Instruct, it has given all of the information pretty much what you have, but it has a lot less information. At the same time, it doesn't have the as much world knowledge as maybe GPT-4 you have, but again, it requires less compute. It has less latency as compared to GPT-4. So this is how you use in the GitHub Marketplace of model. You can also use Azure AI Foundry, and if you go to the model catalog, there are different collections. You can actually choose by collection. You can choose Meta, and it will show you all of the Meta models. You can also choose by the models by, say, industry. Um, as you can see, there are different industry: consumer goods, financial services, health and life sciences. You have different deployment options. There is managed compute, or you can use it as serverless API. We'll talk a little bit about this further ahead. It also gives you a rich set of inference tasks, and you can see there are tons of inference tasks: text classification, text to text generation, translation, token classification, question answering, zero shot classification, embedding models, image classification, image segmentation. So there are speech recognition. So all kinds, different kinds of capabilities are available, and you can see the number of models that are available here, right beside it. And you can see that which of these can be like fine tuned. And if you want to even compare by licenses, you also have that. Like most of them are given under Apache 2.2 or MIT license, which majority of models. So again, I want to show you the different avenues in which you can try out different model, and you can compare each of them with benchmarks as well. So for example, here it will take a little bit of time to generate. You can see different models on the left hand side, and then it will actually plot these different models on one hand. On the x-axis it has a quality index, and another hand it has the cost. So you can see the price to performance ratio of each of those models. You can see that Llama Vision Instruct, it has a lower quality score index, but the cost score is also low. But higher up on the scale, you can see Mistral and GPT-4o, which has obviously higher compute requirements, but also quality of output is better. So you can actually look at the model performance card. So let's go back to the presentation and look at the next demo. So the next demo is I'm going to compare SLMs and LLMs, and I'm going to have a Chainlit app. So again, this app is already available um, in the source code repository that I have. So this Chainlit app, I have just run it. If you read the README, I have actually just run these three instructions, and I have kept it ready so that we don't waste any time in terms of launching it. So I'm just running it using this Chainlit, which is a library to build apps. So it's a RAG app built by Paul Graham. So I'm going to ask it certain questions, and it should give me the answer based on the vector index that I've given it. And for more comprehensive question, it is using a summary index. So I can use a vector index and a summary index, and based on the LLM, and it is deciding the strategy and then routing it to the right index. So I can ask what is Y Combinator, and it's kind of routing the query now. It should give us an answer in a bit. Oopsie, I think it's a little slow. Let me try launching it again. New instance. Hold on. So just as I've done before, so let me just kill this instance and run it again. Okay. Okay. Again, let me ask you the question: what is Y Combinator? And this time the demo gods would be more kind to me, hopefully. Yeah. And you can see that it has given me the answer. It tells that Y Combinator was originally Red Cambridge seed. It was self-funded by Paul Graham until 2009, when it became a fund due to large number of applications. So, I can kind of go on and on, and I can set different parameters. I can set the router LLM to route the request to the right index, or I can choose the LLM model, right? And then again, I have the complete control over how I want to do this. So this is an app that is included along with that repository. And last but not the least, I am going to show you a demo of AI Toolkit for VS Code. So let me just launch that. Cool. So let me just clear my screen. So I'm going to start a new playground. So before I go here, I just want to tell you the extensions. Go to the extension and search for AI toolkit. So AI toolkit for VS Code. And if you search for that, this is the AI toolkit. I have already installed it. Once you install it, you can browse all the models from the model catalog, test the different models in Playground. All of these models, some of them can be run locally and some of them can be run remotely. And once you kind of install the AI toolkit, you will see this on the sidebar. I get this icon. I can again go to the model catalog. All of these model catalog details are available in the blog post, which I will uh, post in a bit. But you can choose, the host, GitHub, Anthropic, Google, ONNX, OpenAI. You can choose the publisher. You can choose the task that you want, and you can choose the locally run models or a remote access model. So we'll get an example of both. So for the sake of time, what I've done is I have already loaded certain models. Um, and I'm going to ask it a question. So similarly, what is a pulsar, which we have prompt that I have given before? As you can see, this is a model that is downloaded locally. Let me just show you. So this is a model that is running on my CPU. As you can see, it is actually running on my CPU, and it should generate some amount, some output. Right, as you can see, it is now actually generating the output, and this is running on my local machine. And it's given a pretty good answer, similar to what we have seen earlier. I have it. The output might be truncated though, because for the sake of time, I have given it max token as 256. But typically, the answer will be longer. Um, I can also use vision. So, like I've already uh, played around with llamas. So, for example, let me use a remote model. I am using this model from GitHub. As you can see, there's a GitHub sign. Let me make this bigger. Yeah, as you can see, I use this model. Then now I'm using the llama model, and uh, now I'm going to choose a demo image. So let me attach this demo image, and I'm going to say what is likely to happen next. So I'm asking it about the image itself, and you can see that it has figured, oh, there is a boy, there's a ball, and the boy is bouncing the ball. So relationship between the image, and if I when I've said what is likely to happen next, it has replied the boy is likely to bounce the ball next as he's standing with his legs apart and legs positioned in a way what suggests he's about to dribble the ball. Right. So again, this is like what is known as multimodal. I've used image as an input and I've given it a prompt, and then it has been able. So I can do fairly complex stuff using combination of image and text. So I would suggest that if you want to try models locally, look at AI Toolkit. If you're using VS Code, go to extension and search for AI Toolkit, and you should be able to download the extension. All of the models are free. You can use them in Playground, similar to what you use for the GitHub Marketplace of model. You will require to once connect it with your GitHub account, but that is the only thing that I am not shown, and you can go ahead with it. So with this, let's go to the next part of the presentation. Um, how do we evaluate the model performance? So there are different ways of evaluating the model performance. There are model benchmarks, model evaluations, traditional machine learning metrics, and AI assisted met metrics. Um, so evaluating your Azure AI language model performance is crucial at every phase of development. You can use it for built-in metrics or quick assessment. You can use custom evaluation flow for tailored insight, and you can ensure that models perform optimally with Azure AI Studio's robust evaluation capabilities. Again, you have an opportunity using SLMs to be able to deploy to different kinds of devices, either on the cloud or on the edge, on your mobile. You can also run it on your laptop using the Windows Copilot runtime. If you go to the link aka.ms/wcr, you can see that. So AI on the edge enables customers to run models on their own devices or infrastructure, which can be closer to the data sources and end users, with or without relying on the cloud. This has many benefits. First, for example, you have lower latency, reduced bandwidth, enhanced privacy, offline capabilities. Moreover, customers need to have confidence that the edge platforms that they can use can support the AI workloads they need with the required level of confidentiality, integrity, and availability. Windows Copilot APIs are backed by on-device ML models, 5 Silica text recognition, and vector embeddings, RAG, text summarization, and more are going to follow with the Win App SDK. So a little bit about ONNX. So ONNX, as we have seen earlier, or Open Neural Network Exchange, if you go to onnx.ai, or Olive, which is an optimization framework, these are tools or toolchains that we use internally at Microsoft. This enable Microsoft developers to use powerful AI throughout our application. And these are also all available as open source to all third-party developers. So we have proven the scale, the performance, and we are now exposing them globally and again uh, as open source, all of these models. So you can kind of use these tools. The ONNX is a portable runtime. It can run across iOS, Android, Linux, Windows. Windows on ARM, with minimal changes, you can use DirectML to abstract across. So the developer can simply optimize one for the whole ecosystem. Today with GPUs, and as NPUs become more and more common, that is neural processing units, you can actually deploy to those as well. So EP here is an execution provider. So you can use high performance portable cross platform. You require less engineering effort. You have better performance. It reduces the burden of developer because you don't have to cross compile as much, and execution providers actually take that burden off you. And as a developer, you have more control over the UX, the resources, and the cost. So the ONNX runtime pretty much runs on every GPU type, and also the newly introduced NPUs that we are using in the Windows AI PC. As I said, it is a cross-platform inference engine for machine learning models in the open standard ONNX format, and supports a variety of execution providers. There's Microsoft Azure, there's QNN by Qualcomm, OpenVINO by Intel, VTC AI by AMD, and so on and so forth, right? It's super easy to actually switch between processor types. It's just a couple of lines of minimal code to make that change, and all you have to do is switch execution providers as you port it to different platform, and you're just recompiling your code on a different platform, right? So it makes life really really easy for developers. um, DirectML is also an interesting use case because it allows you to abstract about the GPU hardware across all GPUs on Windows. So if you need to use the GPU heavily, you just optimize it with Olive once, and then it works across every GPU in the Windows platform. So this is like the toolchain that is available. So Olive simply allows you to get the best performance across all of these different pieces of silicon, and you can generate the sample code in C Sharp, C++, or Python, and then you can plug in the code with minimal modification. So it has already optimized models, and again, this is open sourced as well. So this is like the entire loop on top of Olive that I talked about. I'm going to show you, you post this of it running on my browser. So when I run it on my browser, my video might become a little slow because it'll start, using the GPU. So that is possible. And as you can see that, you can use a Windows app that has a Windows runtime, or you can use a iOS app that has a ONNX runtime. So depending on what you want, you can have this hybrid development parameter where you go to the compile, deploy, run, and again run across, like, either a device or the cloud. that allows you to run different applications, and makes it really easy for you to deploy. So let's see an example of this running on a browser. So let me just switch to the browser. So what I've done is, if you go to this URL, huggingface.co/spaces/webml community 53.5 web GPU, it actually downloads the model. It runs it in your browser. Let me just, it is going to take a little bit of time. So let me just run a prompt. Here I have actually used the 53.5 web GPU. So it takes a little bit of time to be able to run this. And again, this is running in my browser, right? This is the power of like ONNX. I can run it on the device, in the browser, on the cloud, on my edge device, and uh, I can run it on any kind of hardware. It just makes life really easy. This is a runtime web, which is a JavaScript library that enables ONNX model in browser. It has compiled to a WASM backend using mscriptem, if you're familiar with that. And runtime web supports multiple backends such as web GPU, WebNN, to further accelerate the underlying hardware acceleration. Currently I'm running it in on my laptop, which doesn't have like a very powerful which has a powerful GPU, but I'm running it on a slightly um less powerful GPU. Let me just show you the output. As you can see, I'm running it on an IRIX GPU, which is not very great. I also have an NVIDIA, and you can see that it is actually consuming the GPU, and is starting to um, give me an output, right? Like for example, I can see that it has already generated some output, and it is generating token by token, as we have seen. So currently, because the GPU is not very powerful and the model is like pretty large, it's taking a bit of time. But it is possible to run even this kind of small models, small language model 53.5. Again, an SLM, an LLM would be like pretty much impossible to run because of the memory requirements locally. But an SLM is possible to run using web GPU, right? So I want to wanted to give a kind of an extreme example of how to kind of run this. Let me stop this, but you can go to this URL and try it in your browser. Again, like there might be some help needed to configure the GPU, and you can find that in the you can find that in the toolkit as well. So if you go to number 2 and just click on the readme, the link is here as well. So you can just click on the link, and you can try out different kind of models. Um, so I'm going to stop it here. But you can see that it is actually generating the output. Let me just get this off screen. Cool. Let me go back to my presentation. Again, like coming back to what we were saying, choice of models, right? So when choosing between small and large language models, and say we have seen a bit of both, we start by identifying the complexity of the task, and whenever nuanced understanding is required, we can use the large language model. So we have to consider the diversity of languages and the dialects that your model must handle. You need to assess your available resources, computational power, budget, energy consumption, define your desired performance, balancing accuracy and speed, and determine the importance of real time processing. Finally, evaluate the deployment environment. As we can see, we ran it on a browser, we have ran it on a local machine, we have ran it on a cloud, and we've seen this flexibility that we have, and we have to look at the feasibility, scalability, integration with existing systems. So we have to look at a holistic approach that helps you select the best model for your needs. And as you're seeing on screen, we have given you some kind of framework to make that decision. So, when you're looking at AI solutions, I think the first thing that you want to look at is like AI quality, because AI quality is paramount. Eventually, I think the customer is going to uh, uh, judge you on the basis of the output. So you have to focus on accuracy, reliability, robustness, and scalability. So high precision in such prediction ensures accurate output, but consistent performance across different scenarios builds reliability. Robustness allows the AI to handle noisy or incomplete data. As you saw in one of the prompts, I had given a wrong spelling, but it was still able to generate the output, right? And the scalability ensures that the model maintains performance as the data volume and the number of prompts increases. So customization is like key. So the AI should be adaptable. It should allow for fine tuning to meet specific needs. So flexibility is key in supporting various data types and format, and then it should be able to extend new, to add new features and user control or model parameters and settings. It should also be able to consume data, maybe through embedding models of vector databases. Example of which you saw in the ChainL App, for example. Um, and next, you would look at the kind of the features that are available, right? Like, does it have, like, support a certain language, or does it support multimodality, if that's important to you? And finally, when you're deploying this in production, you have to consider price, which is a very critical factor. So consider both the initial cost of acquiring the AI solution, the operational cost for maintenance and updates. You might have to do some training, post training as well, or fine tuning as well. And you look at other parameters such as latency and response time and performance. So again, you have to balance different kind of parameters to make the choice of the model, because once you have chosen the model, all of your application will deploy on the kind of data that it will generate. So the AI Foundry actually makes it easy, or the erstwhile known as AI Studio, to be able to discover and innovate with the best model. And we looked at a model catalog. We have models as a service. We have Azure OpenAI service. It's possible to fine tune with your own data, and Azure AI Search actually allows you to store that data and act as a vector search as well. And eventually, we have support for evaluation and as well. So if you're looking at ways to evaluate for your particular use case, right? For example, you have looked at the benchmarks, and the benchmarks actually, a good analogy would be like if you are passing out of college with a degree. A benchmark is like that. You meet a certain standard, we can expect you to know a certain set of parameters. But for a particular app, it's like a job interview, right? You need to be able to execute that specific requirement very easily. And finally, you should be able to deploy. When you look at deployment, there are multiple different possibilities for deployment. You can use a serverless API, model as a service, or you can use managed compute, models as a platform. Both of them could be useful. Managed compute requires a greater responsibility. A little more fine tuning is possible, whereas all of the overhead of managing the GPUs actually goes away with the serverless API. So if you're looking to scale really fast, one of the ways could be like a serverless API, though it does give you less control. We're coming towards the end of the presentation, so I just want to talk about two concepts. We already looked at one, which is retrieval augmented generation. So retrieval augmented generation consists of three tasks: retrieval, augmentation with the data that is retrieved, and finally use the generative capabilities of the model. So especially it is useful for integrating external data into a language model prompt, so that you can generate the relevant information without modifying the model, because uh, fine tuning or making any kind of changes to the model is expensive. But there might be cases where it is necessary to fine tune a model based on a task specific data set, or adapt to particular nuances and improve accuracy. So both of them offer powerful ways to tailor AI models and to meet your unique requirements, so that we can have relevant and precise output. So um, you have to ensure that there's a high quality domain specific data set to adapt the model effectively. Next, balance between overfitting and underfitting by carefully tuning hyperparameters and other regulation techniques. And finally, monitor performance closely by gauging requirements and making incremental adjustments. So there are certain differences between RAG and fine tuning. So RAG directly updates the retrieval knowledge base without information, without frequent retraining, whereas Fine-tuning stores static data and requires retraining for knowledge and data. RAG is very useful for leveraging external resources, and fine-tuning is very useful for aligning acquired knowledge with large language models, but less practical for frequently changing data. When it comes to data processing, RAG involves minimal data processing because it focuses on information retrieval, whereas for fine tuning, you need high quality data sets. And if you have a limited data set, that can really affect interpretation. Similarly, in terms of computational resources and latency, RAG may lead to higher latency due to data retrieval. Fine tuning is pretty fast because the knowledge is kind of built in the model itself. But fine tuning also requires significant resources for data preparation and training. Um, when it comes to hallucination, I think RAG is slightly better because it can provide grounding answers in the retrieved evidence. Fine tuning can reduce hallucination with specific domain data, but it might still exhibit them with unfamiliar output. So again, like you can choose a strategy based on your model and your requirements. So typically, this is how you would use retrieval augmented generation. So you have the prompt engineering, you have basic style prompting that tells tone and style. You can give example responses, few shot learning, for example, you can map the intent. The retrieval or RAG will actually maybe do things like personalization, look up specific data, can maybe sometimes you can call external APIs and get that. And then all of this re- enriched prompt is finally sent to the LLM, which actually gives you a response, as you can see. Similarly, fine-tuned model has a profound impact on language models by tailoring them to specific tasks or domains, but involves a pre-training model on a smaller specialized data set, adapting to adapt to particular nuances. So again, these are some of the. I mean, I won't be able to go into detail, but again, these slides are available, so you can look at the different kinds of trainings that are available, like CPT, SFT, RLHF. RLHF has actually become really, really popular. So RLHF is reinforced learning from human feedback. So it's a method where reward model is trained using human feedback to represent human preferences. Um, Similarly, we have CPT and supervised fine tuning that can use labeled data sets to actually train the data. So quickly, I'm going to run a demo video um, for this RAG solution before we kind of go to the resources and any questions that we have and wrap up the session.
If you need to use SLM in vertical industries, you must have professional data to combine SLM to complete the fine-tuning task. If in engineering work, we not only have fine-tuning, but also data organization, testing, deployment, and other work, we can regard this process as SLM ops. We have Microsoft Olive's open source tools to help us complete SLM ops work in the cloud and locally. Olive is an easy-to-use hardware-aware model optimization tool that composes industry-leading techniques across model compression, optimization, and compilation. Given a model and targeted hardware, Olive composes the best suitable optimization techniques to output the most efficient models for inferring on cloud or edge, while taking a set of constraints such as accuracy and latency into consideration. I have always called Microsoft Olive a service, because it helps us complete the complete SLM ops iteration. The relevant work is completed through simple configuration. Next, I will show you. We may create a project from AI tools. The project helps me divide the data, model, fine-tuning, and inference functions very well. We can handle different links of SLM ops very conveniently. In the first step, we completed the data processing work. By obtaining the data and organizing it into JSON format, we are ready for fine-tuning. We can use QA Truth on Hugging Face datasets as our fine-tuning data. After completion, we enter the second step, which is the configuration of Olive. We can set the data source just now locally or in the data store of Azure ML, or configure the parameters of the algorithm LoRa or Cloare in Olive, set the converted quantization format, and bind the cloud or local GPU. This is very convenient. It is very helpful for engineering. This example is mainly completed in conjunction with Azure ML. If you want to complete it locally, please use another configuration file. After we set up the configuration of Olive, we can directly run Olive to complete the entire fine-tuning and model generation work. In this example, we can see the pipeline in Azure ML, and each step can be tracked to help us better understand the execution process of each step. Of course, each step will be retained in the cache. For example, here, we can see each step of fine-tuning, model merging, and quantization. Now that we can bind the model and complete the model reference work, you can of course use Notebook and Prompt Flow to evaluate the model.
Cool. So this is an example of fine tuning. Before we end, I just want to quickly talk about the importance of model benchmarks, and we saw this when we looked at the demo on the Azure AI catalog. It works on several different parameters, reasoning, code generation, factual knowledge. And this is like, what is known as a model scorecard. As you can see, there are different models and they're kind of ranked on different kinds of parameters as well. And this kind of helps you do that. Again, finally, there are lots of use cases, that we can look at: the automotive, financial services, telecommunications, retail, um, and and it kind of helps you kind of build applications regardless of what domain you are. Um, and you can see those kind of scrolling on the screen. So regardless of what industry you on and what kind of uh, interfaces you have and what kind of deployment devices you have, we have customers across the board actually using these, like retail, healthcare, manufacturing, fintech, so on and so forth. um, there was a rack demo also, but I'm going to skip that
We
uh,
hope
right now, because we already saw a rack demo in Chainlit. You can actually run this rack demo locally also, when with the repository that I will show you. So quickly, you have to balance cost, speed, and accuracy in RAG model optimization. Um, when you want speed, vector search is efficient, but the retrieval process can introduce latency. When you're looking at cost, vector search can be resource intensive because you're searching a database and then you're using embeddings. So it requires separate data storage and processing power. And because when you're creating the embedding also requires processing power, as well as when you're doing the retrieval also. And RAG can actually boost your accuracy really, really well if you have contextual information really well. So So we have looked at the different power of generative AI models. We have looked at LLMs, we have looked at SLMs, we have looked at proprietary, we have looked at open source, we have looked at different kinds of deployments, cloud-based, on-device, text, image, multimodal. We have also looked at what are the right questions to ask based on the specific task requirement. Um, we also looked at, how do you take the learning and adapt the models for the best needs, because once you have selected the model, you might have to do some extra work either through RAG or fine tuning. We looked at the scenarios in which actually which models work best for which parameters. And finally, we have looked at the opportunity and potential for innovative applications across industry. So with that, I'll stop here and just point to the resources slide. I'll leave this on for a bit. um, you can join our Azure AI Discord, and you can ask any questions. We have many members of the community there. We also have are part of the global AI community, so you can look at the global AI bootcamp and join that community, so you can interact with people locally and kind of skill yourself. Then a highly recommended resource would be Generative AI for Beginners, and you can use this uh, uh, multiple lessons that I think at last count 24, 21 plus lessons that are available, uh, that cover every stage of the AI product development process, right? Whether it's model selection, whether it's fine tuning, the capabilities of different models, the difference between different models, model squads. So everything we have discussed and more is there. And it's kind of a misnomer. It's not just for beginners. Even if you are like a intermediate programmer, I'm sure if you go through the series, you'll find something new that you have not learned. So it's an excellent series. It's updated very often by my team. And you have access to the deck and code if you go to github.com/Microsoft AI Exploring, AI Tour Exploring Cutting Edge Models. And all of the content, pretty much all of the content that we have in this series is available on the AI Tour repo. Before we kind of end, it would be really helpful if you could give us a feedback. So if you please can scan the QR code and give us the feedback for today's session, because we are planning to run this series with different topics. So your feedback is really valuable, and then we can tune this based on your input. So please give us feedback, and I'll just leave this on the screen for a bit. So you can like scan it with your phone, and just fill in the quick form and give us feedback, and we'll kind of use it to improve the series. um, as I said, it is like a series, right? So there are other parts in this series. I showed it at the beginning, and if you joined the session a little late, you can still actually sign up for the other parts of the series, where we have it kind of lined up for you really, really nicely. With that, I'm going to end this presentation on AI Genius series, and I will hope to see you for any question. I will just go back uh, to the moderator and see if we have any questions that we want to
Thanks,
cover.
Vinayak. I think we are at time, so we have our moderators have been doing a great job in the chat. So I appreciate everyone's time, and we wish you all a fabulous day, and we will look forward to seeing you at the next session. Thank you, everyone.
Thank you, everyone.